If you took every star, every planet, every moon, every asteroid, every comet, every atom of gas and dust in the entire observable universe, and spread it evenly through space, the average density would be roughly equivalent to a single grain of sand spread across a volume the size of Earth. 1 grain of sand across an entire planet. That is how empty the universe actually is. And the strangest part is not the emptiness itself. It is why, given that emptiness, anything exists at all. Welcome to Space Review. If questions like this one keep you curious, subscribe and hit the bell. We do this every week. We tend to picture the universe the way it looks in photographs. Dense star fields, glittering galaxies, nebulae blazing with color. But those images are deeply misleading. Cameras collect light over long exposures and compress vast distances into a single frame. In reality, even the most crowded regions of space are almost inconceivably empty. The distance between stars in our own galaxy is so large that if the sun were the size of a grapefruit, the nearest star would be another grapefruit, roughly 2,500 miles away. And between those two grapefruits, almost nothing. A near-perfect vacuum, stretching across an unimaginable gulf. That is the true texture of the universe. And understanding why it is this way tells us something profound about how everything began. The universe did not start empty. In the first fraction of a second after the Big Bang, all the energy and matter that would eventually become everything you see, every galaxy, every star, every atom in your body, was compressed into a region smaller than a proton. The density at that moment was essentially infinite. Then it expanded, and it has been expanding ever since, for 13.8 billion years, stretching space itself in every direction simultaneously. As space expanded, everything in it spread further apart. The density dropped, the temperature fell, and the vast majority of space became exactly what it is today. Nothing. Or rather, almost nothing. Because even the emptiest regions of the universe are not truly empty, and that distinction turns out to matter enormously. Here is what makes cosmic emptiness genuinely strange. The universe is not just mostly empty between stars. It is mostly empty between galaxies. And even within galaxies, the space between stars dwarfs the stars themselves by a factor that is almost impossible to state meaningfully. Our Sun is approximately 1.4 million kilometers in diameter. The distance to the nearest star system, Alpha Centauri, is about 41 trillion kilometers. That means the gap between our Sun and its nearest neighbor is roughly 30 million times the diameter of the Sun itself. Scale that up across the 300 to 400 billion stars in the Milky Way, and you begin to grasp that our galaxy, which looks dense and luminous in photographs, is almost entirely empty space, with a few scattered points of light, separated by distances that would take our fastest spacecraft tens of thousands of years to cross. Then zoom out further. Galaxies themselves cluster together in groups, separated by voids, vast stretches of space where there are almost no galaxies at all. Some of these cosmic voids stretch hundreds of millions of light-years across. The Boötes Void, one of the largest known, spans roughly 330 million light-years and contains almost nothing. If the Milky Way were located at the center of the Boötes Void, humans would not have discovered any other galaxies until the 20th century, because the nearest ones would have been so far away as to be invisible to the naked eye. So why is it all so empty? The answer goes back to the very beginning. The Big Bang did not distribute matter evenly. Tiny quantum fluctuations in the first moments of the universe created regions that were infinitesimally denser than others. Gravity amplified those differences over billions of years, pulling matter into filaments and sheets, creating what cosmologists call the cosmic web. Matter clustered along the threads of that web into galaxies and galaxy clusters, and everything in between drained away into the voids. Emptiness is not an absence of structure. It is the result of structure. The voids exist because gravity pulled everything away from them. Here is where the emptiness becomes genuinely unsettling. Even in the vacuum of deep space, between galaxies, in the most barren regions of the universe, space is not truly empty. Quantum mechanics tells us that what we call empty space is actually seething with activity at scales far below anything we can directly observe. Virtual particles pop in and out of existence constantly, borrowing energy from the vacuum for brief moments before annihilating each other. This is not theoretical speculation. It has been measured. The Casimir effect, observed in laboratory experiments, demonstrates that two uncharged metal plates, placed extremely close together in a vacuum, experience a measurable attractive force caused by the pressure difference between the quantum fluctuations inside and outside the gap. Empty space pushes. Empty space has energy. This vacuum energy is thought to be connected to what cosmologists call dark energy, the mysterious force that is causing the expansion of the universe to accelerate rather than slow down. Dark energy appears to be a property of space itself, meaning that as the universe expands and more space is created, more dark energy is created with it, driving expansion faster and faster. The emptier the universe becomes, the more powerfully it is driven toward becoming even emptier. The universe is not just empty, it is becoming more empty with every passing second. In recent years, the picture of cosmic emptiness has grown even more precise. The Dark Energy Spectroscopic Instrument, known as DESI, released results in 2024, mapping the three-dimensional positions of tens of millions of galaxies across the observable universe. The map revealed the cosmic web in extraordinary detail. The filaments of matter, the clusters at their intersections, and the enormous voids stretching between them, confirming that emptiness is one of the dominant features of the universe at the largest scales. Meanwhile, the James Webb Space Telescope has pushed observations back to within a few 100 million years of the Big Bang, capturing galaxies forming when the universe was still young and dense by comparison to today. Those early images show a universe that was clumpier and more active, already beginning the long process of clustering that would eventually leave most of space barren. Seeing that early stage gives cosmologists a before and after picture of how emptiness evolved, and some of what Webb has found is already challenging assumptions about how quickly structure formed after the Big Bang. The universe is almost completely empty, and it is getting emptier. The matter we can see, every star, every planet, every galaxy, accounts for only about 5% of the total energy content of the universe. The rest is dark matter and dark energy, invisible, poorly understood, and driving the cosmos toward a future in which galaxies drift so far apart that one day, billions of years from now, the night sky of any surviving world will be completely dark. Not because the stars are gone, but because the expansion of space will have carried every other galaxy beyond the horizon of observation forever. We exist in a brief window, a moment in cosmic time when the universe is structured enough to produce stars and planets and chemistry and life, but before the relentless expansion stretches everything beyond reach. The emptiness around us is not a background detail. It is the dominant reality of the cosmos, and we are a tiny, improbable exception to it. That single grain of sand in a planet-sized void is not just a metaphor. It is where you live. If that just made the universe feel a little larger and a little stranger, share this video with someone who needs that feeling today. Tell us in the comments what part of cosmic emptiness you find most difficult to wrap your mind around. And subscribe to Space Review, because next time we are exploring something that sits right at the edge of what science can currently explain. You will not want to miss it.